Okay, we're going to graph inequalities in one variable. First, I'd like to start off with the concept of graphing an equality or an equation. For instance, y equals 3. If y equals 3, then all we have to do is go to a number line, find 3, put a solid dot on it, and we're done. That's the only solution to this equation, is y equals 3. But with inequalities, we could have many more solutions than one. For instance, we have y is less than or equal to 3. So y could equal 3. That's what this half inequality sign means. So we could put a solid dot here at 3. But there's also many more solutions. All the numbers below 3, and they don't have to be just integers. They can be, it could be 2.99. So now we put our solid dot at 3, and then all the numbers that are less than 3 are part of this solution set. So we draw a line all the way down, and we go on to infinity, negative infinity. All right, now sometimes we have inequalities where y will not equal the value indicated. The value is just a border, something that the solutions have to be above. For instance, y greater than 3. Y cannot equal 3, otherwise you'd see a single line here. So we have to put a open dot here at 3. And then all the numbers above 3, and it could be as close to 3 as 3.1 or anything closer, as long as it's not 3. And then we graph it this way. All the numbers above 3 are part of the solution set. Now it gets a little trickier when y is not isolated. Before you can even think about graphing an inequality in one variable, you have to isolate that variable. So now we're going to do just what we do with equations. That's right, we're going to subtract 5 from both sides of the equation. And when we subtract 5 from 5, we get 0. So we have y is less than or equal to, and then we subtract 5 from 8, and we get 3. So you see how these equations are identical now, or inequalities, sorry. You see inequalities are identical, and so now I can put a solid dot at 3, and it's going to be 3 or any number less than 3. Now, there's a very important rule when we're solving for inequalities. If we end up multiplying or dividing by a negative number, then we're going to have to flip the sign because it changes the inequality. Let's see how that works. Okay, here we have negative 2y plus 3 is less than negative 3. The first thing, just like solving an equation, I'm going to add or subtract something if I can. Here I'm going to subtract 3 from both sides. When I subtract 3 from 3, I make a 0. And then when I subtract 3 from a negative 3, remember I have to do just like in addition. When you add and keep the sign, I'm going to add the negatives and keep the sign. So I end up with a negative 2y less than negative 6. Now here's where the flip comes in. Notice I'm getting ready to divide by negative 2. And in an inequality, whenever I'm going to divide or multiply by a negative value, I've got to flip the sign. So the first thing I want to do before I forget, I want to flip that sign. Look how it used to be less than, now it's greater than. And now I can go ahead and divide by negative 2. A negative 2 into a negative 2 makes a 1. So we have y is greater than, and then negative 6 divided by negative 2 is a positive 3. So now I have y is greater than 3, just like this inequality up here. So I do an open dot, and remember y cannot equal 3, but it could be any number greater than 3. And I finish graphing this inequality. So remember, this is the most important rule of graphing inequalities. If you have a negative value and you're going to multiply or divide, you have to flip the sign.